Assalamu alaikum. So in this video, I'm going to show you the proof of converting from the variance covariance matrix system that you see sigma xy over sigma x divided by sigma y into the sum of squares method, ssxy divided by the root of ssxx and ssyy. So first, let's look at the question. The question is that we have to convert the Pearson correlation coefficient from the original method, the most known method, which is in terms of standard deviations and correlations, covariances, into the sum of square methods. So we have this formula given, that sum of square of xy divided by ssxx into ssyy whole under root. So we have to prove this formula, and we have to start from the simple standard deviations and covariances part. So what I did was I started the correlation summation sigma xy divided by sigma x, sigma y. To do this, what I did was, yes. So to do this, what I did was I simply substituted the value of sigma xy, which is the summation of x minus x bar, and multiplied by y minus y bar. So first you have to find this product of x minus x bar and y minus y bar, and then sum all the values to get the covariance between x and y, form of a covariance, not the complete one. And sigma y is the root of summation x minus x bar squared, and this is sigma x. Sigma x is the root of this thing, and sigma y is the root of summation y minus y bar whole square. So putting these three values over here in this equation, this one over here, this one over here, and this one over here, we get the normal correlation formula that we see most often. So once we have this formula, and now in the steps 2, okay. So, in the step 2, what I have done is, because we have two under roots in the denominator, this is one under root, there's another under root, well, I use the product formula. So the product of under root with another under root is equal to the under root of the entire thing. So under root a plus n2 multiplied by under root b is equal to under root ab. Using this formula, we can see that now in the denominator, we only have one under root. The benefit of getting this one under root is because in the original question, we only have one under root. So it's better to have one under root in the denominator and keep it consistent throughout the exercise. So in the next part, in the next step, what I did was I opened this product between x minus x bar and y minus y bar. It's simple multiplication, x times y, x times y bar, x bar times y, and x bar times y bar. So we have 4 terms over here. Okay, once we have this, we can use the summation property. Summation of A plus B is equal to summation of A plus summation of B. So using this property, we can say summation with xy, summation with x bar y, summation with y bar x, and summation with x bar y bar. So we have 4 summation signals over signs over here with each of the components. In the next step, what I've done is I've simply used another property. When you have a constant and a variable multiplied in the summation square, the constant comes outside the summation. It's not going to affect the summation as itself. It's just going to multiply the entire summation by that constant. So over here, x bar and y bar are constants. A mean is always a constant. Mean of any variable is a constant. So what we did was we take x bar out of this and y bar out of this. So you see x bar out of this summation and y bar out of this summation. Next step, use another summation property. When you have summation of a constant, it's n times the constant, the number of observations times a constant. So x bar, y bar are both constants. Their product will be a constant. If this is a constant, and the summation of this will simply be n times the summation of the product, x bar, y bar. This is the only step I did in this. This is the only thing I changed in this step. In the next step, what I did was, so x bar and y bar are actually following this formula of mean. X bar is equal to summation x over n, y bar is equal to summation y over n. So just replace x and y with this formula, and we have these, we have changed the x bar to summation x over n. Okay. Once we have this, what we can see is this a simple product, summation x over n into summation y. That's the same as writing summation x into summation y whole divided by n. And then we have summation y into summation x, and this divided by n. Now, for any constant, when you multiply them, a into b is same as b into a. So I can write this as summation x, summation y divided by n. And over here we have an n divided by n. So we can cancel the n terms. And it's again the same, summation x, summation y divided by n. So after that simplification, what you see is we have 3 terms of summation x, summation y, summation x, summation y, summation x, summation y, whole divided by n, divided by n. So this is with minus sign, this is with plus sign. Just cancel these 2 terms out. What we are left with is summation xy minus summation x, summation y over n. Okay. So this thing we already know, it's been defined for us that summation xy minus summation x summation y whole divided by n is equal to ss xy. So this is the term. Now we have proved the numerator of this thing. In this video, I'll stop over here, and in the next video, I'll start from the step 11. Thank you for watching. Do like and subscribe.